Hello, my name is Sami Alhasan, and I will be talking about bio-inspired approaches for optimizing the strength and toughness of graphene-based polymer nanocomposites. And so the research paper is by who you see in the slides, and so the main specific scope of study for this presentation is going to be enhancing polymer nanocomposites by using graphene nanosheets, in short GN. And the key question is, how does GN increase the mechanical properties of polymers? And so we have So for the methodology, so at first, so the paper is about having the nacre and mollusk shells. Um, it's in the inner layer of the shell, and this shell includes, this nacre has aragonite, which is the main, I guess, ingredient for the brick and mortar structure that contributes to developing a higher mechanical property. And um, for the key research question, so what makes so let me say graphene nanosheets can be um, made into graphene oxide sheets, which are basically more aqueous. They can be distributed in aqueous solutions. And so what makes graphene oxide sheets stronger and stiffer? Um, so this all depends on the H bonds in between the oxygen functional groups, and it also depends on like the water content of those sheets. So depending on what water content you put in, you get a different kind of mechanical property. And also borate cross-linking geosheets proves that it drastically increases the mechanical properties. And second question is, what is the result of combining graphene with other nanoparticles? Um, and for example, what if we combine graphene with epoxy? Um, and the paper shows that the research shows with epoxy, um, usually cracks and deflections occur at low cross-link densities. Um, but even though that happens, you'd get a very strong structure. And also for dye block protein, um, yeah, dye block protein disperses GNs in nanofibrillated cellulose NFC solutions and improve load transfer. And also another method is having is combining graphene synergistically, uh, for example, to carbon nanotubes here to increase the toughness and strength of PVA fibers. And for the summary, um, the key conclusions from the research paper is to have a polymer derived, graphene derived polymer that's lightweight, tough, strong, less prone to fracture, um, all that with low cost. And my personal view of this research paper that it's it's a pretty well made paper. The only thing that concerns me is there isn't any information to where these polymers can be used in the real world specifically. For example, like what kind of application can we use this graphene? Can it be used in the automotive industry? Can it be used in the aerospace industry? So yeah, that's all I have to say. Thank you so much.